This lesson is on solving equations. Equations are actually very useful mathematical tools, as you will come to see. What is an equation? Well, an equation is basically two algebraic expressions related by an equal sign. So you're taking two expressions and forcing them to be equivalent. Solving an equation really means to find all the solutions that will satisfy the equation. So all the numbers that can replace the variable. In this example here, x plus 2 equals 5, the question is, what can possibly be added to 2 to give 5? And in this case, there's one solution, and that is 3. We can take equations and find equivalent equations, and that's basically the process of solving the equations. So equivalent equations have the same solutions. They're the exact same statement, and we can produce equivalent equations by one of three things. You can simplify expressions on each side, as we have previously done. You can add or subtract the same number or term to both sides of the equation, and you can multiply both sides of the equation by the same number, except by 0. If you multiplied everything here by 0, everything here by 0, that'd be distributing. That'd be 0 equals 0. That doesn't tell us anything. So multiplying by 0 is useless. However, multiplying by certain numbers can make it easier for us to find the solutions, which are found when x is by itself on one side. When solving equations, you have three types of solutions. One is single solution. So for example, x equals 3, and that's it. Your other options happen when your variable is completely canceled out when you're solving. So if your x disappears by adding or subtracting it away and it's gone, then you have two options. Either you're left with something that's true, for example 0 equals 0, and in that case any possible x value could have worked for the original equation. Therefore all real numbers is your answer. You can also answer identity. If what you have resulting is false, say 2 equals 3, we know that there is no possible way you could replace the x that was there in the original equation with anything in order to make the end result true, because 2 is never, ever, ever equal to 3. So if your final result is false, you actually have no solution or a contradiction. You can answer either of those answers for those scenarios. Another type of solving equations problem is in the form of a word problem. So let's talk about what process you would go through in the case of an algebraic word problem question. There's a lot of word problems that can be solved algebraically, and so the first thing you want to do is draw some diagrams or map out your key information. Very important to break down your information as much as possible from the word problem before you start really trying to solve any equations or create any equations. Next, you can decide on defining some variables. So for example, you could say let t equal the time traveled, for example. Once you have your variables defined, you can create an equation, solve your equation, and check if your answer is reasonable. Once you're sure, you can state your final answer. Let's look at a few examples. Remember, when we are solving equations, we have the option to add or subtract a term to both sides, or multiply or divide both sides by a number. Our goal is to get the variable by itself on one side. So let's look at number 1. Feel free to pause the video, try it on your own, and then come back and check it out. You can do that to any of these examples. Alright, so we always want to add and subtract terms first to get the variable term isolated as completely as possible, and then multiply or divide at the very end. So let's, in this case, this is our variable term. We want to get rid of the negative 5, so we want to add 5 to both sides, giving us 2n equals 6. Now we can multiply or divide. This is a multiplication by 2. To oppose that, we can divide both sides by 2, giving us n equals 3. You can check your work by filling it in. 2 times 3 minus 5 is equal to 1, check. Next up, we've got a few more things to do. So in general, when you're solving equations, that's called algebra, we've got some steps to follow. First, you always want to distribute. Use the distributive property to release any brackets. That's part of simplifying each side. So here we want to multiply the x and the 3 by 2, giving us 2x plus 2 times 3 is 6, minus 4x equals 7 gets rewritten. So next you want to simplify further, simplify both sides completely. In this case, in this case, that means to collect your like terms here. So you've got 2x minus 4x, which is negative 2x plus 6 equals 7. Once you have simplified both sides completely, you can now work on getting your variable on its own. So you want variables on one side, numbers on the other. And you can use the addition and subtraction property to do that. So here, let's keep the x term on the left side, and let's move the 6 over. So we subtract 6 from both sides. We've got negative 2x equals 7 minus 6, which is 1. At the very, very end, you can multiply or divide, usually divide, both sides by the coefficient of the variable. In this case, the coefficient is negative 2. Let's divide by negative 2 on both sides, giving us x is equal to negative 1/2. You'll notice that the negative can go up front, can go in the top number, can go in the denominator. As long as there's one negative, it is the same number. Let's move on to some bigger examples here. We're going to follow the exact same steps here. So we want to simplify both sides completely, which we can start with distribution first. So let's complete that step first. We're going to multiply negative 2 by 2x and by 5. The 3 stays. So you've got negative 2 times 2x gives us negative 4x. Negative 2 times 5 gives us negative 10. Now we can multiply our negative 4 by x, giving us negative 4x, and negative 4 by negative 6, giving us positive 24 plus 1. We're still simplifying each side. We're still simplifying each side. You want to do that first before you do any algebra, any algebraic steps. So let's combine like terms now. So we've got a positive 3 and a negative 10 on this side that can be combined. So we've got negative 4x and negative 7. Next, we've got 24 and 1, which becomes 25, positive 25, and the negative 4x stays. Now we want to try to get our x's together. And in this case, we've got negative 4x on both sides. So since it's the exact same amount on both sides, we're going to add 4x to both sides. And what happens? Completely disappears. So normally we'd continue the algebra process, but here, that's all we can really do. We're left with negative 7 equals 25. Is that ever true? So this takes us to our example of where the variable disappears. So if it's false, remember it's a contradiction. Or you can answer no solution. And that's it. There is no solution. Let's try the next one. So simplify each side, distribute first. You have 2y minus 2 minus y equals y minus 2. Collect like terms. 2y minus y is 1y minus 2 equals y minus 2. Get y's together. So you're going to subtract y, you're left with negative 2 equals negative 2. Well, that's a true statement. What that means is no matter what you put into those y's, it doesn't matter. It's always going to be true because they're always going to cancel out. So if it's always true, your answers and your solutions are all real numbers. You could also state identity if you like. Alright, let's look at some examples with fractions in them. So whenever you have a fraction in an equation, what you want to do is, the easiest thing to do is to eliminate the fraction. So to eliminate the fraction, you can use the multiplication property, which states that you can multiply every single term of an equation by the same number. And to determine a number that will help us, we look at the denominators of our fraction. So in this case, number 5, the only denominator here is negative 5. So you want to take the common denominator of all your numbers. So in this case here, number 6, 2, and 3, the common denominator would be 6. So we'll look at that in a second. So number 5, let's multiply both sides by 5. Better yet, let's multiply by negative 5. That way, the negatives here cancel out. You're left with just x equals negative 4 times negative 5, which is 20. Done. Next, this example here has more terms, so you have to be more careful. Keep any multi-term numerators together in a bracket so you don't forget to distribute. We look at the denominators. The LCD, the lowest common denominator of 2 and 3, is 6. So let's multiply everything by 6. Every single term has to be multiplied by 6. Otherwise, the equation will not stay in balance. Alright, so let's do some simplifications here. 6 over 2 becomes 3. 6 times 3 is fine. 6 over 3 becomes 2. And that's about it. So let's continue. So really, we have 3x plus 6 times 3 is 18 equals 2 times 2x plus 5 minus 6. So we've just rewritten it so that we have no fractions, we don't have to deal with them. Let's move on. So we want to distribute first. 3x plus 18 stays. Equals 2 times 2, 4x plus 2 times 5, 10 minus 6. Collect like terms. 3x plus 18 is 4x, and 10 minus 6 is 4. Okay, now we're at the stage where we have simplified each side. That's all we've been doing so far. Now, here comes the algebra step, where we add or subtract and then multiply and divide. So let's get our x's together. Now you could choose to take the 3x over to the right, or you could choose to take the 4x over to the left. My preference is usually to bring the smaller one to the bigger one. So the bigger one has more. You want to keep it there because then that will eliminate the possibility of you forgetting a negative in the end, basically. So let's subtract 3x to both sides. Now, you could have subtracted 4x. It's totally fine. Either way, it'll work. So here we have 0. Here we have 18 equals 4 minus 3, which is 1x plus 4. And now you want to get your numbers together. So x's together, and then numbers together. And then at the very end, you can divide if needed. That's basically your algebra process. So let's subtract 4 from both sides, leaving us with x equals 14. Okay, this next one here, we've got a little bit of room. Let's get rid of the fraction. So we've got a denominator of 5, so let's stick things in brackets and multiply every single thing by 5. So here that goes away. We're at 2t minus 18 equals 5t minus 15. Let's get our t's together. Let's bring the 2 to the side of the 5 because 5 is bigger, so minus 2t minus 2t. We get negative 18 is equal to 3t minus 15. Move over here. So I'll rewrite that. Negative 18 equals 3t minus 15 is where we're at. And we'd like to combine our numbers now, so let's bring the 15 over to the left, giving us 3t equals 3, negative 3. And our final step is to divide, giving us t equals negative 1. One final word problem here. Let's take a look. A business suffered a loss of 9,540 in its first year. So that's minus 9,540. In its second year, it made a fairly large profit plus some number of dollars. If the total profit, total implying adding together the profits over the first 2 years is 12,690, how much profit was made in the second year? So I've just sort of categorized what's happening. We lost some money, and then we gained a bunch of money, and then we got a total of 12,690. This business did, actually. So let's label our variables. Let P equal profit. Therefore, that part was P. So we had negative 9,540 plus some amount of P is equal to 12,690. And we have made our equation. Now we can solve. So we want to move this guy over, add 9,540 to both sides. Giving us $22,230 as our profit in the second year because I had to make up for the loss and then gain some.